Okay. So therefore, what is PA minus PB? Pressure difference between 2 points. Clear? No? L is length of the pipe. R is radius of cross section of this pipe. So write down R value also. R is called what? Radius of pipe. Okay, ma? So therefore, the rate of flow of fluid flowing through this pipe. What is meant by rate of flow? Already we have discussed. No? Rate of flow means what? The volume of liquid flowing per unit time is called as rate of flow. So this is given by pi p r power 4 divided by 8 eta L. Okay, ma? This equation is called as Pascal'S equation. Okay. So pi means pi only, p means pressure difference. P means what here? Pressure difference between two ends of the pipe. At one end pressure is PA, at other end pressure is PB. Okay. And R is radius of the pipe, R power 4. 8 eta is coefficient of viscosity of the liquid. L is length of the pipe. Are you able to understand, ma? So therefore, this equation gives the equation of Pascal, or you can call it as Pascal'S equation. Q is called what? Q is called as rate of flow. Eta is called as coefficient of viscosity of the liquid. Okay, that's it. This is called as Pascal'S equation. Okay. So if you try to change the volume of this fluid, you cannot change the volume of this fluid. So such type of fluids we can call them as incompressible fluids, or we can call them as ideal fluids. Okay, ma? So then we study that, okay, ma, fluids always exert perpendicular force only. Perpendicular force to the surface in contact. Okay. So fluids, water, air, all of them, they are fluids. So all these fluids, they exert only perpendicular force only to the surface in contact. What is the meaning of this one? Sima, for example, if I take a tank of water, okay, and consider this is a body present in this tank, okay, then on this body, this water will exert a force in which direction? Clear, ma? So it will exert a force only in perpendicular direction only. Okay. So always perpendicular to the surface in contact. Okay. Similarly, if you consider the bottom of this tank, on the bottom of this tank, force is applied in this particular direction. Similarly, on the sides of this tank, force is applied in this particular direction. So force is always applied perpendicular to the surface in contact. So this is how nature behaves. This is how these fluids behave. Okay. Now how can you prove that fluids exert only perpendicular force? Let us see. See, ma? For example, consider this is a tank of water. Okay, ma? And in this tank of water, let us consider water is exerting force at this angle, at a particular angle. So what is this arrow I have drawn? This is the force exerted by water on the base of the container. Then by Newton's third law, what happens? By Newton's third law, base also applies an equal and opposite force on the water. Okay. So therefore I will draw that force here. Okay, ma? So therefore, what is this force? This is a force exerted by the base of the container on the water molecules. Okay. Now if I split this force into two components, I will get two components. So if this is angle theta, I will call it as F cos theta, and this is F sin theta. Okay. Now what is this F cos theta? F cos theta is the horizontal force applied by the base of the container on the water molecules. It means definitely there is a component of F cos theta, and because of this F cos theta, water molecules should start moving in this particular direction. Okay. So continuously water molecules should move parallel to the base of the container, but that is not happening. That doesn't happen. It means that this F cos theta does not exist. Okay, ma? What is this F cos theta? Force applied by the base of the container on the water molecules. This F cos theta should not exist. Okay. So if F cos theta should not exist, so F cos theta is 0, then it means that cos theta is also 0. So it also means that, okay, ma, theta is equals to how much? Theta is equal to 90 degrees. This is what we understand. So theta is equal to 90 degrees means what? This force cannot be like this. This force should be like this. Okay, and if this force applied by base of the container on the water molecules is in this direction, it also means that water is applying force exactly in downwards direction or perpendicular to the surface in contact. So therefore we say that fluids always exert perpendicular force to the surface in contact. So this is one point which you should be very careful. So similarly, if you take your hand, so air is also a fluid, number. It also exerts force in which direction? It also exerts force perpendicular to your hand in every direction. Okay, so fluids always exert perpendicular force to the surface in contact. Okay, so then we study about the next topic, which is called as pressure. Okay, now let us try to understand what is meant by pressure. Okay, so see, pressure. So what is meant by pressure? Pressure is nothing but force per unit area is called as pressure. Okay, and in total fluid mechanics, we generally use the term pressure only instead of force. What is the reason? Because, for example, if I take a tank of water, clear, Nama? On this tank of water, applying force at one point is not at all possible. We cannot apply force at a single point. Clear, Nama? Because water is not a rigid body, so you cannot apply force on water at a single point. But on this water, if I want to apply force, then what I can do on the surface of this water, I can place a piston. Okay, ma? I can place a piston. So below this piston, water is present, and now I can apply force on this water. Okay, so area of the piston is A, force applied is F, then pressure is equals to force per unit area, then this condition is satisfied. So therefore in fluid mechanics always we use the term pressure instead of force, because applying force at a point is not possible, but force can be applied on a surface area. That is the reason. Okay, so here one more point which we study is, let us see importance of pressure. Okay, importance of pressure. See, what is the importance of pressure? We know that pressure is equals to force per unit area. No? Pressure is nothing but force per unit area. So pressure can be increased if force increases or area of contact decreases. If force increases, definitely pressure increases. Similarly, if the area on which we are applying the force, if that area decreases, then also pressure increases. So what is the meaning of this one? Okay, ma? So example we study is sharpening of knife. Sharpening of a knife. Okay, so consider this is a watermelon, and this is a knife which we have placed, and with this knife I want to cut this watermelon. So if I sharpen the knife, what happens? The area with which this knife goes into contact with the watermelon, that area of contact decreases. If area of contact decreases, automatically for the same force which you apply, pressure will definitely increase. Okay, so therefore if you reduce the surface area of contact, then pressure automatically increases with the same application of force. Force we are not changing, we are changing the surface area which this knife is touching that watermelon. Are you able to understand? So this is the importance of pressure. Okay, and one more point which we should observe carefully is, pressure is a scalar quantity, it is not a vector quantity. Okay, ma? So one more point which you should write is, pressure is what kind of quantity? Pressure is a scalar quantity. Okay, ma? So what is meant by scalar quantity? It does not have any particular direction, so no direction. Or you can say that pressure does not depend upon direction, it is a scalar quantity. Okay, so what is the reason? Already we have studied, Nama. For example, if I take, this is the body which is present inside water, and force is acting on every direction. So how can you say that pressure is acting in only one direction? Force due to pressure, it is acting in every direction. So therefore pressure does not have a particular direction, so it is a scalar quantity. Okay, so after that we study about pressure due to liquid column. Okay, ma? So the next concept which we are studying is pressure due to liquid column. So let us see. Okay, ma? So pressure due to liquid column. Okay, sigma. For example, consider this is a tank of water. Okay, ma? So area of cross section of base of this tank, area of cross section, or just you can say base of tank, area of base. So let that one be A here, and the height up to which the water is filled is H, and also mass of water which we are taking is, let it be M, mass of the water is M. Okay, ma? Then how can you calculate pressure? Pressure is nothing but force per unit area. No? The force of the total water which is acting on the base of the container is nothing but pressure. Okay, 1 minute. Okay, ma? So therefore in this condition, what is the force exerted by water on the base of the container? It is nothing but weight of the water. Okay, ma? Weight of the weight of water is mg divided by area. So therefore pressure can be written as, mass can be written as density into volume into g divided by A. And volume can again be written as, volume of this total water I can write height multiplied by area of cross section. So area of cross section multiplied by height multiplied by g divided by A. Clear, nama? So therefore I can cancel A and A, therefore pressure is equals to rho hg. So this is the equation to calculate pressure because of height of a liquid column. Okay, ma? So pressure can be calculated in terms of Pascal, in terms of Newton per meter square, and while solving problems, pressure will be given in terms of height of liquid column also. Ma. Why? Because pressure only depends on height of the liquid column itself. Are you able to understand? And surely it depends on density and g values. If liquid is same, rho value remains constant, and if planet is same, g value remains constant. Okay, if liquid doesn't change, rho remains same. Rho means the density of the liquid does not change. Okay, so therefore here what is the most important point we have to make a note? Note point is that pressure only depends on height of liquid column. Okay, ma? Height of the liquid column. What are the conditions? Rho comma g, they are considered to be constants. Okay, ma? Density of liquid and acceleration due to gravity, they are considered to be constants. Okay. Now here one more point which we should understand is what is meant by h here. H means what? H is only vertical height of the liquid column. H should be taken as only vertical height of the liquid column. So what is h here? H is called as vertical height of liquid column. Okay. Now see, ma'am. For example, if he asks a question like this, okay. So let us try to understand what is happening here. Okay. See, ma'am. For example, he has taken a test tube like this. Okay, ma'am. And water is filled in this test tube. Water is filled in the test tube. Okay. And height of the test tube or length of this test tube is 1 meter. It is bent at an angle of 37 degrees. Then find the pressure due to water. This is water, ma, at the base of test tube. At the base of test tube. Clear, ma? So consider this is a question which is given. So because of this liquid column, I want to calculate a pressure at the base of the test tube. Clear, nama? Then in this condition, the effective length is not L here, because L means what? L means only vertical height of the liquid column, no? So here I cannot take L. So therefore what I will do, this L, I will split this one into two components. Clear, nama? So this is 1 meter, this is 37 degrees. So this is 1 cos 37 and this is 1 sin 37. So 1 sin 37 value is 3 by 5. So it is only 3 by 5 meter. Okay, ma? Because we are supposed to take only vertical height of the liquid column, so vertical height will be how much? Vertical height will be only 3 by 5 meter. So therefore, how can I calculate the pressure? Pressure is equals to rho hg. Already we have calculated, no? Clear, no? So density of water is 1000, height of the liquid column is 3 by 5 meter, and g value is 10. Clear, no? So therefore, 5 1s are 5 2s are 6,000. Okay, so 6,000 Newton per meter square. Okay, so therefore this is the pressure due to liquid column on the base of the container because of this 3/5 of vertical height of the liquid column. Total height we are not concerned, we are concerned only about the vertical height itself. Okay, ma? So this is called as what you call the equation of pressure. Okay. Then we study one more important interesting concept which is called as hydrostatic paradox. Okay, ma? So again based on the concept of pressure itself. So hydrostatic paradox. Okay. So what is meant by hydrostatic paradox? Let us see. For example, this is a tube and we are placing different types of openings to the upper surface of this tube. Okay, ma? Okay. So these are the different heights we are taking and water is filled in them. Okay. Then I see that in the first shape of this open tube, I see that water is up to this level. Okay, ma? Water is up to this level. Now the question is, in the remaining openings, what will be the height of the water? Water will be present up to which height? Okay. Then the answer is that in the remaining pipes also, water will be present up to same height only. What is the reason? Same vertical height only. What is the reason? Already we have studied, no, ma? For example, if you take 3 points, okay, so consider this is point A, okay, ma? And consider this is point B, and consider this is point C, okay, or you can take here point B, here you can take this is point B. 3 points I am taking, okay, ma? Then at all the 3 points are at same height, so definitely pressures at 3 points also must be equal according to Pascal's law. So therefore what I can say, pressure at point A is equals to pressure at point B is equal to pressure at point C. This is what we take. Okay. So at all the 3 points, pressure remains to be same. So therefore if pressure remains to be same, the height of the liquid column also must remain same irrespective of the size and shape of the open tubes which are present. So therefore it appears like something weird. So that is why it is called as a hydrostatic paradox. Now it appears to be very weird. Okay. That is the reason. Okay. So therefore then we study about pressure difference due to liquid column. Okay, ma? Pressure difference due to liquid column. So let us. So pressure difference due to liquid column. Okay, ma? Now let us see what is the meaning of this one. Okay, see, ma? So consider this is some liquid. Okay, ma? And I want to calculate pressure difference between 2 points. For example, consider this is point A, okay, ma? And consider this is point B. So I want to calculate PB minus PA, pressure difference between point A and point B. So these two I want to calculate. So let us see. See, ma, let us consider total height of this liquid column is H. Total height of the liquid column is considered to be H. Now I see that this point A is present at a height of H1, okay, ma? H1, and this point B is present at a height of H2. So one is present at a height of H1 and point B is present at a height of H2. So therefore what is pressure at point A? Pressure at point A is rho H1G and pressure at point B is rho H2 into G. So therefore what is PB minus PA? PB minus PA is nothing but, clear, no, ma? So it is rho H2G minus rho H1G. So therefore rho G, if I take common, then it is H2 minus H1. Okay, ma? So this height, this is not what we are supposed to take, ma? Let us correct this one. So the distance between A and B, the distance between A and B, I will take it as H. Which distance? Vertical distance. Vertical distance between A and B is considered to be H. Then definitely H2. H2 minus H1 is nothing but H only, no? Okay, ma? So H2 is the distance of point B from the top of this water layer. Similarly, H1 is the height of point A from the top of the water surface. Clear, no, ma? So therefore I can write pressure difference between 2 points is also written as rho Hg, because H2 minus H1 also can be written as H. Okay. So therefore, for pressure difference also we use the same formula rho hg. Okay, ma? But here what is meant by h? H is nothing but vertical distance between 2 points A and B. So PB minus PA is equals to rho hg. Okay. So this is how we can calculate pressure difference between 2 points in liquid, any liquid or any fluid also. Okay. Okay. Now here let us study one more interesting point, ma. So dependence of pressure on acceleration due to gravity. Okay, ma? So dependence of pressure on what? On acceleration due to gravity. Okay, acceleration due to gravity. Okay, see, ma. For example, if acceleration due to gravity of Earth has become 0 suddenly, Earth's acceleration due to gravity is 9.8 meter per second square, we'll know already. So if acceleration due to gravity becomes 0, then what is the pressure difference between 2 points? PA minus PB is equals to rho hg will become 0. Okay, ma? Why? If g value is 0, total pressure difference will become 0. So it means that pressure difference between 2 points is depending on what? It is depending purely on the acceleration due to gravity of a particular planet. So therefore what I say, if acceleration due to gravity, of a planet, okay, ma, becomes 0, then pressure difference, okay, ma? So then pressure difference will become 0. Okay. So this is very interesting point, ma. So pressure difference is existing between any 2 points in water only because of the acceleration due to gravity. Because pressure basically it is because of weight of water on the base of the container, and weight is because of g value. So therefore pressure difference is also only because of g value. Clear, ma? So after this we will study about a very important law which is called as Pascal's law. Okay. So let us try to understand what is the meaning of this Pascal's law. Okay, ma? So in Pascal's law we have two statements, ma. Both statements are one and the same, but same Pascal's law can be defined by using two statements. Okay. So let us see. So Pascal's law. Okay. So first statement we are writing. So first statement of Pascal's law is if 2 points are at same height in same liquid, okay, ma, then pressure difference between the 2 points, is 0. Okay, ma? So this is called as first statement of Pascal's law. Clear, no, ma? For example, if you take any fluid or any liquid and you take 2 points which are at the same height, at the same position, so then definitely we can say that pressure difference between them will be 0. Okay. So we are taking 2 points, ma. This is point A and this is point B, and both of them they are at the same height. Then definitely I can say that pressure at point A is equals to pressure at point B. So this is one statement of Pascal. Now let us study about the second statement of Pascal, ma. Okay. So second statement of Pascal. Okay. So what is the second statement of Pascal? If by any means, okay, ma, pressure is increased at one region, okay, ma, then same increase in pressure, is transmitted is transmitted throughout the liquid, is transmitted throughout the liquid in every direction. Okay, ma? So this is called as second statement of Pascal. It means that by using any means, if you are able to increase pressure at a particular region in water or any liquid, then the same increase in pressure will be transmitted in every direction throughout the liquid. So this is called as second statement of Pascal. Okay, ma? Now let us try to understand the second statement of Pascal by taking an example. Okay, see. So consider this is a tank of water, ma? And in this tank of water, we are fixing some 2 to 3 pistons, let us consider. So this is one piston. Okay, ma? Piston means a valve which can move up and down is called as a piston. Okay. Similarly, here we are fixing another piston. This is the second piston, ma? Clear? And here we are fixing one more piston. So this is piston number 3. And this total tank is filled by some liquid, say it is water. Okay. Each piston has different surface areas. Surface area of the first piston is A, its surface area of the piston is 2A, and the surface area of the third piston is A by 2. Okay, ma? Then on the first piston, I am applying a force of F. I am applying a force of F on the first piston. So if I push this piston downwards, I observe that this second piston and third piston, they will start coming outside. Because if I start applying force on one piston, liquid will be tried to compress, and that force is transmitted in every direction. It means other pistons also, they will try to come in outwards direction. Now the question is that how much force I can apply on second piston and third piston so that these pistons doesn't move. Okay. It means the force applied on first piston, let it be F2, and force applied on third piston, let it be F3. Clear, Nama? Now we are supposed to calculate F1 and F3 values. How can I calculate? I can calculate this one by using the second statement of Pascal. So what is the second statement of Pascal? So if we are applying a force of F on a surface area of A, then what is the increase in pressure? Increase in pressure is F by A. Okay, ma? So this is the pressure which is increased at the first piston. Now the same increase in pressure is transmitted everywhere. It means on the second piston also same F by A pressure should increase. Similarly on third piston also F by A pressure should increase. So therefore how can I do? Therefore I can write F2 by 2A must be equal to F by A. Okay, ma? So here also F3 by A by 2 must be equal to F by A. Okay. So what is F2 by 2A? Increase in pressure. F3 by A by 2, that is also increase in pressure. And increase in pressure must be equal to F by A. Clear, Nama? So therefore, what are the terms I can cancel? A and A if I can cancel. So F2 is equal to 2F. Okay, ma? And here if I calculate F3, what is F3 value? F3 should be equal to how much A and A get cancelled. Okay, ma? So it should be equal to F by 2. Clear, no? So therefore, a force of 2F should be applied on this piston so that that piston should not move. Similarly, here on the third piston, I have to apply a force of F by 2 so that this piston does not move. Are you able to understand? But what was the force we were applying on the first piston? On the first piston, we were applying just a force of F only. But here I have to apply 2F and here I have to apply F by 2. Okay, ma? So why different forces we are getting? Because surface areas are different. Okay, ma? Though increase in pressure is same, but surface areas are different, So pressures also will be different. So these are the two statements of Pascal's law. Okay, ma? Make a note. Then you will understand. So keep the next second. Gauge pressure and absolute pressure. Gauge pressure and absolute pressure. Okay. So what is meant by gauge pressure? PG, gauge pressure. Gauge pressure is nothing but pressure due to only liquid column. Okay. If you consider pressure only because of liquid column, then it is called as gauge pressure. Then absolute pressure, PA, or just you can call it as P also. Absolute pressure. What is meant by absolute pressure? Absolute pressure is nothing but gauge pressure plus atmospheric pressure, P atmosphere. Okay. Now first of all, let us try to understand why we got absolute atmospheric pressure also in this statement. Okay. We will try to understand with the help of Pascal's second statement. Able to understand? Answer very carefully. See, if I take this as a container, in which liquid is present, or some part is present, so this is a container. Okay. So in this container, here at point A, which is at a depth of h, if I calculate the pressure, then can you say how much will be the pressure? Bro? No. So total pressure at point A will be pressure due to gauge pressure plus atmospheric pressure. Two pressures will be existing at this point. Able to understand? At this point, pressure due to liquid column is gauge pressure. Able to understand? What is gauge pressure? Gauge pressure is pressure only because of liquid column. But in addition to that pressure, atmospheric pressure also will be present. Okay? Atmosphere is here now. Here is a fluid only. So every fluid exerts pressure. So therefore, what I can say is, see, at the topmost surface of this liquid, at the topmost surface, atmosphere will be giving its pressure. Are you able to understand? At the topmost surface of the liquid, its pressure will be present. Atmospheric pressure will be present. So here there is an increase of P atmosphere. Okay. So on the top surface, there is some increase of pressure because of atmospheric pressure. And the same pressure will be transmitted everywhere. Are you able to understand? For example, if I take 2 points. So let us consider this is point B and this is point C. At point B, what will be the total pressure? So let us consider this height is H1. Okay. So one pressure is because of gauge pressure. Okay. And here atmospheric pressure has increased now. So same increase of atmospheric pressure will be present here also. So in addition to gauge pressure, atmospheric pressure is also present. Are you able to understand? Atmospheric pressure, where it is acting? On the top surface. So their pressure has increased now. And what is Pascal's second statement? If pressure increases at one point, same increase will be presented everywhere. So throughout the liquid, there will be an additional pressure of atmospheric pressure. In addition to which pressure? Gauge pressure. Gauge pressure means pressure due to liquid column. So totally how many pressures will be there? 2 pressures will be there. One is pressure due to liquid column and another one is pressure due to atmosphere. Is it clear? So therefore, this is at a height of h1 now. So therefore, how can I calculate the total pressure or absolute pressure at point B? So it is gauge pressure. Gauge pressure is rho h1g plus atmospheric pressure. Are you able to understand? And the sum of gauge pressure and atmospheric pressure is called what? It is called absolute pressure. So in a liquid, at every point, there will be 2 pressures. One is pressure due to liquid column and the second pressure is atmospheric pressure. Are you able to understand why atmospheric pressure is acting everywhere? Pascal's second statement. Here on the top surface, atmosphere is giving some additional pressure. So that pressure is transmitted at every point inside the. That was only pressure due to liquid column. Previously we calculated which pressure? We calculated pressure only because of liquid column. Person would allow getting also. In the questions also previously what I should have asked, what is the pressure at this point? Because of liquid column. I did not ask absolute pressure. Are you able to understand? Similarly, if this is a point to C, if this is at a height of H2, now can you say what is the total pressure at point C? Total pressure at point C is how much? Rho H2G plus atmospheric pressure, because atmospheric pressure is present everywhere. Is it clear? So that is the application of second statement of Pascal. Is it clear now? So therefore, what is the note point I can write? The note point is that atmosphere gives additional pressure. Atmosphere gives additional pressure on top surface of liquid. On top surface of liquid. Okay. Same increase in pressure is transmitted everywhere in the liquid. It's transmitted everywhere in the liquid. Able to understand? At one point we are increasing the pressure, so same increase of pressure is transmitted everywhere in the liquid. That is called as the concept of second statement of Pascal. Is it clear? Clear? So now we will write some applications of this Pascal's law. Okay. So first very important application which was asked many times in the previous examination is hydraulic lift, or you can call it as hydraulic press. Okay. First application is hydraulic lift, or you can call it as hydraulic press. And the same concept you can use for hydraulic braking also. In lorries and big vehicles, you will see hydraulic braking now. And Pascal's law only, this hydraulic braking system also will work. Okay? Now let us. So, let us draw a rough diagram of the hydraulic lift now. So this is a simple construction of hydraulic press or hydraulic lift. Okay. So here there is a construction in which two pistons are arranged. So this is the first piston which is having an area of A1, and this is second piston which is having an area of A. So let us consider A1 is equals to how much? 1 centimeter square, and A2 is equals to 1000 centimeter square. Everyone understand? Areas are different. See now. Let us see first of all what is the application of this hydraulic lift or hydraulic press. In bigger cities, you will be seeing a parking of cars. Have you seen? Cars are very huge in number nowadays. So what they do, they will construct floors for parking the cars. First floor, second floor, third floor. Okay. So you go and park your car on this hydraulic lift. Then the lift lifts this car upwards and it will place in the respective floor. First floor, second floor, like this. So when I was in Tamil Nadu, there was one hotel. In that hotel, this arrangement was placed on. Parking of the cars by the hydraulic system. Are you able to understand? See, what will be the mass of a car? Approximately, you can take it is 1000 kg. So this is a car. Mass of the car is how much now? 1000 kg. Are you able to understand? So to lift this car, how much force we have to apply? Force is nothing but weight of the car. Now weight formula is mg. Mass is 1000, mg value is 10. So how much force you have to apply? 10,000 newtons of force you have to apply to lift this car. Are you able to understand? Mass of the car is 1000 kg. Weight of the car will be 10,000 newtons. So if you apply 10,000 newtons of force on this car, then only you can lift the car upwards. Okay. But by applying very small force, we are able to lift the car with the help of this hydraulic machine. How it is. See? So here, I will apply a very small force here. Force here. Are you able to understand? And I can move this car force. Is it clear? Now can you say how much force I have to apply here so that I can lift the car upwards? See now, if this piston goes downwards, this piston moves upwards now. Clear? These are movable pistons. If I move this piston downwards, automatically this piston should move upwards. And wherever I want to place this car in the parking system, I can place the car. Are you able to understand? Now can you say how much is this F1 line? How much force I have to apply so that I can move the car upwards? Anybody? I want to solve this problem by second statement of Pascal. What is second statement of Pascal? If I increase pressure at one region, same increase in pressure is transmitted everywhere in the liquid. By using that concept, can you say how much force I have to apply? Actually, how much force I have to apply? 10,000. Then only I can move the car upwards. Okay. So here, how much force I have to apply? Which statement you said? How much pressure you are increasing at one area? Same increase in pressure is transmitted everywhere. So here, what is the increase in pressure? At the first piston, what is the increase in pressure? At the first piston, increase in pressure is how much? Force per area only. Force is how much? I don't know. Area is how much? 1 centimeter square. That's all. And the same increase in pressure is transmitted everywhere. And that pressure is responsible to lift the car upwards. So what is the increase in pressure there? Second piston. Okay. So at the second piston, how much force should be applied now? Force is how much? 10,000 Newton force should be applied. Then only it moves upwards. Clear? So second piston increase in pressure should be equal to F1 by 1 centimeter square is equals to 10,000 divided by 100. What is the area of this one? 1,000 centimeters square. This is how I have to write it. Here increase in pressure is force per area. What is the force? 10,000. Area is how much? 1,000. So force per area. And this force per area is equal to this force per area. Because here increase in pressure is F1 by A1. Same pressure should be present here also. And that is equals to 10,000 by 1,000. Are you able to understand? Is it clear now? To move the car upwards, this is the force I have to apply. So that force should be applied. Is it clear? So this is the force, 10,000. Now do the calculation. So therefore, F1 value will be how much? 10 bucks. Okay. So if I do this total calculation, I will get F1 is nothing but only 10 Newton. So what do you understand by F1 is 10 Newton? What we understand? We understand that just by applying 10 Newton force, I am able to lift this car upwards. That is what I understand. Actually, how much force I have to apply? 10,000. But how much force I am applying? Only 10 Newton. 10 Newton is a very small force. Clear now? It is a force of 1 kg body. What is the weight of 1 kg body? 10 Newton. 1 into 10, 10 Newton only. It means just if you place 1 kg stone on this piston, you can see the car moving upwards. Is it clear? So that is the advantage of Pascal's second step. Are you able to understand now? If you are increasing pressure at one region, same increase in pressure is transmitted everywhere in the world. That is how nature is clear. Okay. So just a force of 10 Newton is converted into a force of 10,000. Is it clear? That's it. So therefore, what is the note point we have understood here? A very small force of 10 Newton is converted into a force of how much force? 10,000 Newton. Okay. So that is the beauty of Pascal's. And same concept we use in hydraulic braking system also. Clear? So at the pedal where the driver is applying the brakes, he will apply very small force. Okay. But that force is converted into very big force so that it is able to even stop even the lorry also. Okay. Lorry is easy, cycle is a very big body. And you have to generate very huge force. So what we do, we place this arrangement, this force is applied on the tire of the lorry. And this is the force applied by the driver. Are you able to understand? He applies very small force. So very small force is converted into very big force. Automatically it is enough to even to stop the lorry also. Clear? Yes. So let us see this problem now. So a large can crusher. So this is a can crusher. So this is a piston, and on the top of the piston, you will have a very strong arrangement. Okay. So in between this piston and this arrangement, cans can be crushed. Can crusher. Okay. So shown in the figure, so large piston has an area of 8 mm square. So this one has an area of 8 meters square, and exerts a force of how much force it is exerting? 2 into 10 power 6 newtons of force it is exerting. So calculate F1 due to smaller piston. So what is the force I have to apply on smaller piston? So F1 value I am supposed to calculate, and what is its area? Area is 10 centimeter square. So this F1 value I have to calculate so that I can generate a force of 2 into 10 power 6 newton. That is the question. Now first of all, if this is the area and this is the force, then what is the increase in pressure? First of all I have to calculate that one. So pressure on second piston. What is the formula of pressure? Pressure is equals to force per unit area. Force is how much? Force is 2 into 10 power 6 divided by area is how much? 8. So therefore how much is the pressure? 1 by 4. 1 by 4 means 0.25. So 0.25 multiplied by 10 power 6. Or I can write 25 into 10 power 4 Newton per meter square. That's all. So this is the pressure acting on second piston. Because of this pressure, it is able to crush the cans. One point I got clarity. Now this increase in pressure should have been supplied by whom? The increase in pressure ever supplies is first piston should have supplied. Okay? But the problem is that first piston and second piston, they are not at the same height. That point also I have to take into consideration. These two pistons, if they are at same height, I can say pressure on first piston is this much, pressure on second piston also same. But there is some what you call liquid column height also is this. It means that pressure due to liquid column also I have to take on into consideration. So what is the pressure due to liquid column? Pressure due to liquid column is how much? Okay. Pressure due to liquid column? Rho H. Density of water? 1000. H value? 1 meter. G value, shall we take 10? We shall take 10. But this person has taken 8.8, we will take 9.8. So how much it is? 9800 Newton per meter square. So 3 zeros. 9800 Newton per meter square. So therefore, at the base of this tank, what is the pressure due to liquid column? Pressure due to liquid column is 9800. And the same increase in pressure will be acting here also. Are you able to understand? See, pressure is a scalar quantity, it doesn't have any directions. Okay. So because of liquid column, if this is the increase in pressure, same increase in pressure will be present here also. So therefore, on the first piston, totally 2 pressures are acting. What are the 2 pressures? One pressure is the increased pressure, which is transmitted up to here. And the second one is pressure due to water column. Are you able to understand? So what is the total pressure acting on the piston? Total pressure is 25 into 10 power 4 plus 9800. These 2 pressures combinedly is acting on the first piston. Are you able to understand what is happening? Clear now? This is pressure because of what? This is the pressure because I am applying pressure on the first piston. That increase in pressure is transmitted up to here. And pressure due to liquid column is also there, no? At this point, there is some additional pressure now. Additional pressure is because of what? Take of the liquid column. And that pressure also will be present on first piston because these 2 points they are at the same height. Are you able to understand? So therefore, what I say, therefore I say, on first piston, this is called first piston. On first piston, 2 pressures are acting. 2 pressures are acting. Okay. So therefore, what is the total pressure acting on first piston? Pressure acting on first piston is how much now? So it is the sum of 25 into 10 power 4 plus 9800. This much amount of pressure is acting on first piston. Okay. Once I calculate pressure, can't I calculate force? Because pressure is nothing but force per unit area. Clear? So okay. Okay. So therefore, we know that pressure is equals to force per area. So what is force? Force is equal to pressure into area. So therefore, force is equal to pressure is how much now? So it is 25 into 10 power 4 plus 9800 multiplied by. And what is the area of this piston now? Say first piston? 10. Units also we have to see. 10 centimeter square now. So 10 into 10 power minus 4 meter square. Clear? 10 centimeter square here. I have to convert into meter square. So 10 into 10 power minus 4 meter square. If you do this calculation, whatever answer you will get, that will be the pressure acting on the first piston. Sorry, force acting on first piston. And the answer which he gave me is 260. So 260 is the answer. Okay. Have you understood how we have done the calculation? See, both pistons, they are not at same height now. Height is different. If height is different, pressure due to liquid column also will act on first piston. There. The second piston, it is at the top position, so liquid column pressure will not act on that. But on the bottom piston, pressure due to liquid column also will show its pressure. So 2 pressures are acting. Is it clear? వెంటనే సీన్ మారిపోతుంది. ఏమనికి అర్థం కావాలి క్వశ్చన్స్ వెంటనే మారిపోతుంది. ఈ చాప్టర్ నీట్ లెవెల్ వరకు ఇట్లా తుపారు క్వశ్చన్ ఇస్తారు. మెయిన్స్ అడ్వాన్స్ పోయే లోపల క్వశ్చన్ అర్థం కావచ్చు. Okay. So one point which we forgot is pressure is a scalar quantity. See here, for example, if this is a body and pressure is acting in every direction. So therefore, what is meant? Force is acting in every direction. So what is pressure? Pressure is nothing but force per unit area. Force is a vector quantity. Force is a vector quantity, but still pressure is not a vector quantity. What is the reason? Because if you take any body, pressure is applied always perpendicular to contact surface one. So here, this surface, if you take, force is acting at an angle of 90 degrees. Here, if you take, force is acting at an angle of 90 degrees. So everywhere, pressure is acting in, you can say force is acting in every direction. So therefore, there is no particular direction for force. So therefore, pressure also does not have any particular direction. So pressure is a scalar quantity. It doesn't depend on directions. Clear now? So let us say this question now. So 2 pistons of hydraulic lift have diameters of 50 cm and 2.5 cm. So what is the force exerted by larger piston when 50 kg weight is placed on the smaller piston? If the stroke of smaller piston is 4 cm, find the distance from the larger piston after 10 strokes. Okay. So let us see. First of all, let us draw a rough diagram of this picture now. So this is a smaller piston and this one is a bigger piston. Okay. So liquid is filled inside this compartment. Okay. Now, is the diameter of this smaller piston? Diameter is 2.5 centimeter and this diameter is 30 centimeter. What is the force exerted by larger piston? So this F2 value we are supposed to calculate. And how much weight we are placing on smaller piston? On the smaller piston we are placing the weight of 50 kg. 50 kg weight. Okay. So therefore we can consider both of them they are at same height, because if you did not mention anything, it means that both pistons they are at the same height. So what is the increase in pressure on the first piston? Same will be the increase in pressure at the second piston also. So pressure formula F1 by A1 is equals to F2 by A. I want F2 only now. So F2 is equals to F1 by A1 multiplied by A. Now just substitute the values. Clear? So therefore F2 is equals to, what is F1? F1 is 50 kg mass, but I have to convert into weight. 50 kg weight means what? Weight of 50 kg. What is the meaning? 50 kg weight means weight of 50 kg. So how to convert mass into weight? By multiplying with the g value. That's all. So F2 is nothing but F1. F1 value is how much? 50 into 10 divided by area of cross section. Pi d by 2 whole square I have to write down, and you need not convert into meters, because here also I have to convert into meters, here also I have to convert into meters, so they will get cancelled with each other. So I can write A2 value is how much? A2 value is pi d by 2 whole square divided by A1. A1 is pi into d1 by 2 whole square. That's all. Area of cross section pi r square only, but diameters are given, so I am writing d by 2. Is it clear? So therefore F2 is equals to pi 2 get cancelled, pi 2 and 2 get cancelled. So therefore F2 value is 50 into 10 multiplied by d2. D2 is how much now? 30. So I can write 30 square divided by d1. d1 is 2.5 square. That's all. If you do this calculation, you will get the force which is acting on second piston. Force on second piston only is asking. So therefore answer which you should get is 7200 kg weight. 7200 kg weight he gave the answer. It means that we will get one more zero number. So 72000 weight you can say is your words. This is yours. Is it clear? Okay. So he also gave answer in terms of 7200 kg weight. Kg weight means again one more g value I have to multiply. Is it clear? Now what is the second question? Second question is, if the stroke of smaller piston is 4 centimeter, it means once you apply pressure on the smaller piston, it goes down by how much distance? It goes down by 4 centimeter. That is the meaning of it. Okay. So if this smaller piston goes down by 4 centimeter, I have to calculate a bigger piston moves upwards by how many centimeter? How can you say it is 4? 4 and we can answer. Able to understand now? Smaller piston for one stroke, it goes down by 4 centimeter. Then bigger piston should move upwards. No? It moves upwards by how many centimeter? By based on which calculation can I do it? Yeah? Come on. Completed for this one? Completed? Anybody? What is the distance moved by larger piston for one stroke?
So density into H into G.
No need of density. Density is it changing here? No. What is the need of density here? Anybody? Sima. Very simple. Based on volume of the liquid you can do this calculation. Sima. So what is the volume of the liquid going down? Same volume of liquid will move upwards. No? Volume of liquid always remains same. So if some volume of the liquid is going down here, same volume of liquid should move upwards on the other side. So volumes should remain constant. Here if you twist the piston downwards, once the water local get the water is local get water pike. So volume of water which is moving up and down, it should be constant. Common sense water. Is it clear? So therefore what we say, volume of water going down at the first piston is nothing but volume of water moving upwards at second piston. Okay. So what is the volume of water going downwards? Same volume of water should go upwards. Understandable point. Clear? So therefore I can say V1 is equals to V2. So based on this calculation we are doing now, V1 is nothing but V2. Volume formula, area of cross section multiplied by length only. So A1 L1 is equal to A2. Area of cross section of the first piston, pi d1 by 2 whole square. Length is 4 cm. Area of cross section of second piston, pi d2 by 2 whole square. multiplied by L2. So pi 2 get cancelled. So therefore, diameter is 2.5 whole square multiplied by 4 is equals to, what is the diameter of this one? 30. 30 square multiplied by L2. So if you calculate L2 value, you will get it is 0.027 centimeters. Okay. So what is the distance moved by bigger piston? It is 0.027 centimeters for one stroke. But he is asking us to calculate for how many strokes? 10 strokes. So therefore, for total 10 strokes, what is the distance moved by? Distance moved by bigger piston is summarized. It is equal to 10 into 0.027. It is equal to 0.27 centimeter. That is nice. Is it clear? Very, very simple.